So you are asking about KT,
Yes, sir.
the clearness index, right?
Yes, sir.
See, there is, nowadays there is meteorological data available of various parts, because satellite imaging is very popular, and then the meteorological section will give you the data if you ask. Uh, um, what we have done is that we have taken the data that was actually measured at various parts of the country, and based on that, because we don't have the data on every square inch of the latitude, right? That is not available with us. And then the sensors have been placed only at some resolution. So across 12 different places in the country, these measurements were there taken by the metallurgical department, and also by Professor Annamani in RRI, Raman Research Institute. She has done very lot of work on collection of data, not only the solar data, wind power data, and all those things, and kind of model the entire country, how the pattern of availability of the solar insolation. So we took that data of across 12 cities, and based on that, we created a Fourier series model. All right. So that is the starting point for that. Now, KT is the clearness index. Okay. Now, you know what is the measurement at the outer atmosphere of the Earth, where there is no constraint on vapor absorption, water vapor, atmospheric condition, particulate matters. All those things are not there. At the outer extraterrestrial radiation, we say. At that point, that is measurable. And what is measured is at the surface of the Earth. And thereby dividing, you can get the KT at these locations where it is measured. So that is the KT value which is at those locations. Then by making this Fourier model, you get the KT at any other continuous location. So that is how you go about getting the KT, if you are not having at that specific location. So you first try satellite data, meteorological department you contact, try to get that satellite data. If it is not available, then you can use the model. Is that clear, Santosh?
Yes, sir. Water vapor content also same, sir?
Yes, water vapor content is also same. You can also get data on water vapor content in a like manner. Instead of solar insolation, it will be water vapor value at that particular horizontal column, right there. If I'm here in the horizontal column up to the end of the atmosphere, you will get the data on that one. So it is, there are sensors which will measure that, and then you can get.
Sir, actually, sir, we are on the private institute, sir. This is
Yes.
so. How to get this data, sir, in a realistic manner, sir? Actually, we said that one of the Raman Research Institute, there is one source given with data.
There is one, you can refer to that book. In fact, I had used data from that book to develop that model also. So that data is a valid data. It's a 50-year-old data, spanning 20 to 40 years. So it's quite a large span time window. You can get the summary of those data in one book called book written by Professor Annamani.
Yes, sir.
Solar radiation data by Professor Annamani. So that is available. That you can get it, or you can go to the satellite data. If you go to Red Screen, RETSCREEN, Red Screen is another open source kind of resource, which also gives satellite data at different latitudes.
Okay, sir.
Okay.
Red Screen, sir.
Or you will have to approach, the meteorological department. You have to You have to write to them and ask them to share the data. They will do that.
Sir, there is any thumb rule, sir, for deciding the locations, or are you are randomly taken such 12 locations?
Which locations? The locations which were for which the data was actually collected, you are saying?
Yes, sir. Yes, sir.
No, no thumb rule. It is because those were the places where actually sensors were placed by the people to collect data. So we use that as the actual data as the reference point.
Okay. Sir, actually, KT can be measured by the ratio of the HAT by H naught, sir. So H naught you are measurable according to the our declination D number. And sir,
H naught is also calculatable accurately
yes, sir.
because without the atmospheric effect, you calculate H naught, right?
Okay, sir. On if the
If
HAT
atmospheric
measure,
effect is not there, H naught calculation is very straightforward and it is accurate.
yes, sir.
There is no uncertainty there. Uncertainty comes in only when atmosphere comes in.
Is no instruments are to measure the atmospheric energy.
Pyranometer. You can use pyranometer.
Yes, sir.
It will give you a measurement of the actual insolation at that point. You heard of pyranometer?
Yes, sir. And that suppose in our location, I suppose of a particular midday of the month, I will using the pyrometer. I will take some readings, sir, divided by
Yes.
that H naught calculated by our by instead of the declination and day number. So I want to measure the KT is a accurate value, sir.
Yeah. Yeah, it will means it will give you a value for that particular instantaneous value that you have taken. See, KT is statistical, right? It is kind of varying over seasons. See, in a year, you will have the summer month, you will have the spring month, you will have the monsoon rain month, you will have the winter months. All these months are there, right? Where the atmosphere condition is changing. Water vapor condition is also changing. So it is not one measurement that is sufficient. You will have to take several measurements over the year. Then that will give you a statistical averaging of the KT value, clearness index value.
Okay, sir. Sir, otherwise simply I will use the same KT matrix as you provided. I will change
Yes, you
my
can do
latitude.
that because that is internally having a statistical averaging because the data has been taken over several years.
Okay, sir. The same KT and vapor control matrix we are using, just change our latitude. It gives the HAT minimum is the accurate value, sir. Or you are
Yes, it will give, but you are yeah, that you can do. That will give.
yes,
That,
sir.
that will give within whatever the statistical percentage error is there, it will give.
As it is, whatever you provided the KT
Yes.
and W matrix
You can
using.
use that model. You can use that model which I have given you in the class.
Okay, sir. Just I will change
Both
our
water
latitude.
vapor model, use both the water vapor model and the clearness index model, it will work.
Okay, sir. Sir,
It will.
already you told this HAT minimum also the approximate value in your lecture.
Yes.
So
Because everything is statistical, no? So that is why,
yes, sir.
see, when I say that in Bangalore, 5 kilowatt hours, I get per meter square at my place, I can say. But that tomorrow it may not be 5 kilometers hour. Today it may be 5 kilowatt hour. Tomorrow it may be very cloudy. And it may come down to 1 kilowatt hour. Or then when the sun comes out after all this depression, it may even reach 8 kilowatt hours. So we say it is on an average. So that is where the approximation comes in. No one can be sure.
Okay, sir.
Hmm.
So, sir, another question, sir. Sir, in the week 11, sir, three-phase grid connection, sir.
Yeah.
Sir, in your finally three-phase simulation block from MPPT, you are taken IM, sir, current output from MPPT block that directly
Yes.
gives to the ID block, sir.
Yes.
So because of transformation, ID also DC and IM also DC, sir. Contour.
Yes.
Sir, how to
Yes.
get the IM from MPPT block, sir? There are only direct and indirect control, sir. One is duty cycle and one is how to get the current as MPPT output, sir.
Correct. So, see, MPPT itself is a closed loop operation, right?
Yes, sir.
So, what are you doing? You're doing, you're sensing the power, and based on the power, you're adjusting the duty cycle of that MPPT.
Yes, sir.
right? In an MPPT converter, when we were doing the MPPT part, you are not adjusting the duty cycle. You are just measuring the power, and then you are giving it as a reference.
Yes, sir.
Okay.
Yes, sir.
Now, let us say that I have given a wrong reference.
Yes, sir.
So that MPPT output is given as ID reference, right?
Yes, sir.
I given a wrong reference, let us say. See, that value of the current whichever you are giving reference is the one which is going to be injected to the grid.
Yes, sir.
So at the grid, voltage is defined. There is nothing nobody can touch about the voltage. 400 volts means 400 volts. 230 volts means 230 volts, right?
Yes, sir.
So the only thing that is variable and controllable is the current that you are injecting.
Yes, sir.
So whatever the current reference that you have set here, let us say, is injected into the grid. So that grid voltage into the grid current, what you are injecting, is the power that is being delivered.
Yes, sir.
Correct. Now that power that is being delivered is the one that you are sensing, and then you are going to the MPPT algorithm. Then you are checking. Okay, it is still not reached maximum power. Then it will adjust the duty cycle. It will adjust the value, and then give that value to your as a new reference to your ID, and that is the ID that will be again fed in. And then voltage being constant, again voltage into the current will be the power that is calculated, and that will keep on, the MPPT algorithm will keep on adjusting the reference till maximum power is delivered to the load. So any other adjustment, you will see that the power would be lesser than whatever it has given at the maximum power. Just like you would do in a MPPT algorithm. In the MPPT algorithm, you are adjusting the duty cycle, you are adjusting the reference.
Yes, sir. But in simulation, how to get the output as current value, sir? Yeah, you are giving current input output as to ID, sir. In MPPT, only direct control duty cycle is one of the output, or voltage is one of the outputs, sir.
Yeah,
Just to.
but the output of the MPPT is a output of a controller, right?
Yes, sir.
So the output of the controller is what you set, what you define as what you want it to be. Because output of the controller has no value, it does not have any units, or it does not have any relationship to anything unless you define it. So during doing the MPPT converter, I defined it to be representing the duty cycle. The value coming from the MPPT controller, I used it for defining the duty cycle, and therefore when I give it to a triangle, it gave me a pulse width modulated waveform. In grid connected, I am defining the output of the MPPT controller to represent current. So therefore, when I compare it with the current, so accordingly you will have to compare. So when I am comparing there for duty cycle, I am comparing it with a triangle waveform, which is 0 to 1. And therefore, accordingly, I am going to get 0 to 1, the duty cycle going from 0 to 100%. But here, because it is a current, I am comparing it with a feedback current, what I am sensing. So therefore, automatically it will take the units of the current.
Okay, sir. I understand, sir. But how to get the current, sir, from the simulation? Because in the up to now we are taking only duty cycle as output from the. We are giving V and I as inputs for functional block, getting T as the output, sir, from MPPT. Or otherwise, there is a indirect voltage control, voltage V reference as output, sir. Only how to get the I
See,
as output?
what is the output of the controller of the MPPT?
Yeah.
What is the wave shape? What is the wave shape?
So, wave shape, sir.
What is the wave shape at the output of the MPPT controller? Is it DC?
Wave shape control. Yes, sir.
It is DC, right?
Yes, sir.
If I compare that DC with a triangle, then I will get output which is duty cycle.
Yes, sir.
If I don't compare it with a triangle, if I compare it with another DC, I will get an error DC.
Yes, sir.
That error DC is the one which is going to correct for the current.
Yes, sir.
Okay, so depends upon where you are taking the taking the reference. So in the case of the three phase, you are taking at the output of the MPPT controller, which is a DC value.
Yes, sir.
So that I'm defining it as the current reference.
Yes, sir. Yes, sir.
And I want my feedback current to match it.
Yes, sir. Yes, sir.
You got the point?
Yes, sir. I understand, sir. But my query is, sir, are you saying with respect to hardware point of view, sir? But in a simulation, sir, suppose I'm taking a MATLAB simulation file. I'm using the function block generate a MPPT control, sir, giving V and A as input, sir, for function block.
Okay.
Up to now, we are using only direct control as D as output, sir. Writing a program or say some P and MPPT or incremental conductors. V and I are inputs, D as output, sir.
And what is the D? D is, oh, you are output of that one, you are using D. And then is the D converted to pulse widths?
Yes, sir. D converted to pulse width like that, sir. But how to get the
How are
IM
you
as output?
converting it to pulse widths?
That gives to pulse width PWM generator, sir. D is given to.
You will now not give it to a PWM generator. You will give wherever you are giving D,
Yes, sir.
you will give that D, you will rename that D to IM and then give it to the current.
Okay, sir.
Got the point?
Yes, sir.
Because that is the point of DC. And the closed loop will automatically adjust that value.
Yes, sir. Right, yes, sir.
Closed loop will, the MPPT controller will automatically adjust that value to reach a maximum power point value corresponding to that.
Yes, sir. That portion I understand, sir. Entirely how to
So
inject
in
the
your
current.
simulation, wherever you are having the D value, that D value, you take it and then give it to the IM reference, ISD ID reference value.
Okay, sir. Okay, sir.
You will rename that D value to ISD reference.
Sure, sir.
Okay. Anything in the chat? Let me see what is there. Does any agency in India doing recycling of aged solar panel? No, I don't think this is going to be a problem. This is a very important challenge that who Rajnikant has raised. How does one recycle solar cells and panels? So the first generation solar panels must are reaching around 15 to 20 years age, and they will be at the end of their useful life, and recycling is a very important challenge. So in India, I don't know still if anybody is doing that, but this is world over a big problem that is going to come. So someone will have to give a big thought to it and then try to be enterprising about that. Anybody else?
Sir, why lower order harmonics are gives a very significant impact compared to higher order harmonics, sir?
In which one?
In the last week's PWM techniques, sign PWM.
Yeah, see what happens. You take a square wave. You take
Yes,
a
sir.
square wave. Okay, square wave of some 50 hertz. You take. Okay.
Yes, sir.
Now the fundamental is 50 hertz, right? Then third harmonic will be 1 by n. That's 1 by 3 of the flat top value. then you will have 1 by 5 of the flat top. So you will see that there is a kind of a what should I say, hyperbolic kind of a decrease that will happen at the harmonic value because of the divide by n.
Yes.
Okay. So if you if you plot everything and then see, you will see close to the 50 hertz. That's what we say lower order harmonics will have higher amplitude and magnitude. They are dominant. And as you start going to higher and higher frequency, the divide by n starts going, making that smaller and smaller, attenuating it, and they gradually become insignificant. So that is why the low order harmonics are very important from the point of view of their high amplitudes, and you need to take care of those distortions.
And what is the relation, sir? Because filter size and this harmonics, sir. So if the order of harmonics are lower harmonics, you will increase the filter size. That's why we are switching frequency increase for operating the band within the high frequency range, sir. So what is the relation between the size of the filters and the harmonics, sir?
Which filter you're saying? Which filter and about which filter you're talking of?
So generally, we are connecting the output of the inverter to the filters and for the grid, sir.
To the grid. Okay. So there, see, what we normally would do is that, see, you are doing DQ control,
Yes, sir.
right? So when you are doing DQ control, you are trying to switch at some high frequency value,
Yes, sir.
right? And the harmonics are of that order,
Yes, sir.
okay? And I can afford to go in for an inductance which is a lower value, smaller value, right? But that inductance should pass my 50 hertz.
Yes, sir.
But it should create impedance for high frequency and harmonic values.
Yes, sir.
So you will design according to what is the lowest frequency for which I need to design my filter. So if it is 10 kilohertz or 5 kilohertz, depending upon what is the lowest sideband that you want to take care, you will design the filter to accommodate that frequency. All higher frequency will anyway get taken care of because it will provide more impedance for higher frequencies than what you are designing.
Yes, sir. Sir, why SPW restricted to 100% modulation and space factor as you are saying 114%, sir?
Yeah. See, in the case of SVPWM, we are adding a third harmonic component,
Yes, sir.
right? The reason why we are adding a third harmonic component is a sine wave. You take a sine wave. Sine wave is having a rounding top, right?
Yes, sir.
A rounded top. So when I am having a modulation, my triangle waveform, the top of the triangle waveform, if I consider it as one, the sine wave top should not peak, should not reach more than one, right?
Yes, sir.
Now let us say that I add a third harmonic. So what will happen? Third harmonic is having three tops within a half cycle.
Yes, sir.
Sorry, two tops within a half cycle and one negative top.
One negative top, sir. Yes, sir.
Right. So it will pull down our center top of the fundamental.
Yes, sir.
It will make it a bit more flatter, right?
Yes, sir.
And so your same fundamental, which is having unity height, will be pulled down, and I am able to modulate this well within my unity triangle.
Yes, sir.
So I can push my fundamental still higher to hit, so that fundamental plus the third harmonic will just be at the unity.
Yes, sir.
Which means the fundamental must be higher than unity, right? Because the one with unity I had pulled down with a third harmonic. For me to just touch the modulation band, 100% modulation band with a third harmonic, I can use a fundamental higher than 100%, right?
Yes, sir.
So if I use 114% and the third harmonic, the center part of that fundamental will get pulled down just directly, just below the
One value, sir.
modulation band.
Yes, sir.
Just below the modulation band. So that is the advantage. So we are able to get more percentage of the fundamental in the SVPWM as compared to the normal one. So normal one, if I say is 100%, this will be 114.
Yes, sir. Why it is not possible in sine PWM, sir?
This is the reason I told you. No, you are not adding a third harmonic. If you add a third harmonic there also, you will get the same advantage.
In sine PWM also gives the same extra mileage, sir. You are when injecting the third
Sine
harmonic.
PWM, if you take pure only sine PWM,
Yes, sir.
you have one sine wave and a triangle comparison.
Yes, sir.
So the sine wave can go only up to 100%.
Okay, sir.
To that sine wave, you add a third harmonic. Then I can go up to 114% and still have the composite waveform below the triangle modulation band.
Yes, sir.
That is the advantage. So sine PWM, if you take, you can go only up to 100%. Sine PWM plus third harmonic you add, you can go up to 140.
Yes, sir. That means third harmonic injection will be applicable for both the sine PWM and also SVPWM, sir.
SVPWM, it is already inherent. It is there. Sine PWM, you have to consciously add.
SVPWM inherently, sir. Inherently is third harmonic injection, sir.
Yes. Because of the way you would do the computation of the vector.
Okay, sir.
Anybody else having any other doubts? All of you are crediting, is it, for your college courses?
Yes, sir.
Okay. Do you find it hard? You can also, now that I have made some notes, this one book available, ebook is there. You can download the ebook, or if you are having Kindle, you can read it through Kindle and Unlimited, so that some reference is there for you guys.
Sir, I said that in SVPDM, sir, by injecting the Triplen harmonic, it does not affect the current wave and the line voltage, sir.
Yeah. No, what did you say? What did you say?
When added the Triplen harmonic, sir,
Yeah.
it does not affect the line voltage waveforms or current waveforms. So, can you elaborate and explain it, sir? That's change.
Because there is no rotational component, no?
Yes, sir.
See, you have the triplen harmonic, third harmonic.
Yes, sir.
Is multiplying every. So normally in a fundamental, you would give sine omega t minus 120, sine omega t minus 240.
Yes, sir.
Now all these three, when you vectorially add, you will get a rotating rotating vector.
Yes, sir.
Now if you take triplen, 3 into 120 is 360. 240 into 120 is 360 into 2. So there is no spatial phase difference. They all come and land up at one point. So there is no rotation. So triplets won't rotate.
Zero
So
sequence
there
power.
won't be any effect. So there won't be any effect on the voltage waveform.
Okay. Both phase and line are, sir. Only line voltage, sir.
The phase and line are only by a scaling factor, no?
Yes, sir.
So it should not affect even the line or the phase voltage. Impact of on-grid system on grid. Sagar is asking, Sagar, what do you mean by impact? What impact are you talking of? Is it impact in terms of dynamics? Is it impact in terms of harmonics? Is it impact in terms of cost? What is the impact that you are talking of, Sagar? Increasing of no inertia generation dynamics. Yes. See, when you take the solar photovoltaic system and you are injecting power into the grid, you are doing it at very high dynamics. You are doing it at a very fast time span. You are talking of dynamics of the order of milliseconds. But when you talk of the grid, thermal grid, which is coming from the thermal station, majority of the Indian grid is coming from thermal stations, 70 to 75% of it. And that is having a time constant which is very, very, so it will take some 8 hours to 10 hours for it to reach a steady state. So this is going to be a serious problem. This is one of the problem that people are facing as the photovoltaic system is kind of taking over the grid. So what happens is that, let us say during the daytime, you are taking from the photovoltaic system and then pumping it into the grid. So there is sufficient power. And then the moment 6 o'clock happens, 6 o'clock in the evening, photovoltaic power does not contribute. So there is not enough power generation capability in the grid. The thermal generators will have to kick in. The thermal generators, for it to kick in and reach stable state, will take 8 hours. So what will happen? So that is when grid fluctuations and grid sagging, all those things will happen. Grid instability starts coming into picture because of this large dynamics. This is a stiff system. The photovoltaic system is very fast, but the thermal system is not. So you need to have buffers in between, which means you need to store some energy in battery buffers, and these battery buffers will have to come and support the system till the thermal generators have kicked in. And then the morning again, the whole cycle starts. So this is a problem and this is a challenge. Yes, this is a very good challenge that someone can work on. Clear, Sagar? Did I clarify your point? So let's see. Brahmeshwar Rao is asking, in case of single phase on-grid inverter system connected to a three-phase distribution transformer with neutral on secondary, is there any unbalance of load on secondary of the distribution transformer? If so, how? See, when you are talking of a three-phase, of course, all the transmission distribution is all three-phase. And if you are having a single-phase grid-connected system, solar grid-connected system, if you connect it to only one phase, there is going to be imbalance. So one of the phase you are putting power, other two phases you are drawing power. So the distribution transformer is going to see a imbalance, and because of that imbalance, you will see the negative sequence and zero sequence currents flowing in. Neutral currents will be there. So it is always good to connect a three-phase inverter to the three-phase system, or there has to be a conscious effort done so that every alternate home is connected to a different phase. So the first home is connected to phase A, second home is connected to phase B, third home is connected to phase C, and A, B, C. Like that, it should go in that kind of a sequence. Then there will be some kind of grid balancing. But grid balancing needs to be done. It's an important thing. Otherwise, you will have neutral currents flowing. Is that clear, Brahmeshwar? Anybody else wants to ask question on the chat? You can ask the chat. You can put your question on the chat also. Mhm. Which MPPT technique is used in real-time system? See, all the MPPT systems that I have discussed, voltage reference, current reference, then perturb and track observe, right? They are all practical MPPTs which are employed in practical systems. The voltage reference and current reference are actually practical systems which are used. And the one that I discussed, the hill climbing. The hill climbing is a very popular method which is independent of the type of the panel, and you can also use it if there is shading coming into picture. So all these are practical methods. The power slope method was popular sometime before, but now more and more the hill climbing algorithm, also called as perturb and observe algorithm in several literature, is the one which is more popular. Anything else? Anybody else want to ask any question? You can write in the chat also, or you can unmute your microphone and ask the question. How can we improve the output power of PV panel tested in the laboratory with artificial illumination? Example, 40 watt peak. We are getting only 20 watt max. See, if you are using artificial, you should understand that the photovoltaic panels are designed for the solar spectrum. So in the solar spectrum, you have around 40 to 50% in the infrared region, thermal, and then there is another 40% which is there in the uh, visible visible light region, and then another remaining percentage in the high frequency zone. So the PV panels are all tuned. The band gaps are all tuned to react to the visible spectrum of the sun. So the energy in the visible spectrum is the one which is going to produce the power by raising the electrons as a free electrons by taking in the photon packets. Now, in your artificial illumination, you should check the spectrum. What is the light spectrum the artificial illumination is giving? If it is not having enough power in the band, in the wavelength band of the visible spectrum, if it is not close to the sun spectrum, then you will not be able to get the full maximum power that it is rated for. So for that, you will have to actually change the artificial illuminations light source. Is there no? That spectrum you will have to change, which means that you will have to change that light source and get a spectrum which is close to the solar spectrum. Then you will be able to improve the output power coming from the PV panel being tested in the lab. That you can check. Is that clear? Is that clear, Sagar? I hope I've answered your question. Can you deliver a course regarding EV? You want a course on EV, eh? Means in this photovoltaics course or as a separate course? Does India get potential to manufacture solar panels in India? Yeah, there are several people who are manufacturing solar panels in India. The wafers are brought out from outside, but making the PN junction and encapsulation and packaging is done by several companies in India. Separate course, okay. EV is another this one. Yeah, we can try to. I will try to make another separate course on EV. I will because we have done a lot of work on EVs. A lot of our students are working on EV related problems, and then a lot of work has been done. Yeah, probably sometime I will try to give a course on EV. Yeah, the temperature. See, all panels are designed for standard temperature and insulation. That is for benchmarking. So when you want to sell panels or outside the country to want to sell, there has to be a standard benchmark. So 25 degrees centigrade is a standard benchmark which everybody uses all over the world. But definitely, of course, in India, the temperature is much higher in several places, and there will be a deterioration of efficiency for every degree centigrade. There will be a fall in the efficiency, but that will be taken care of. That will be accounted for in the nomographs that they give, the data sheets they give at different temperatures. But for benchmarking and comparing, people normally take the standard temperature.
Yes, sir. If there is no question, you can wind up, sir.
Yeah. Okay, guys. If there are no questions, then we will wind up. And I will wish you all the best. Do well in the exam, and hope you all do very well in future. Thank you.
So in future, if they want any question, they will ask in discussion
The
forum.
discussion forum, I will try to get it answered that way. Yeah.
And last question came, sir, from
Do we use same converter technology for EV and solar? Yes, the converter technology won't change. The power electronics will remain the same, but the way you will give the controls, the way you will give the pulse width modulation, they will change. So at the control level, it will change, but at the hardware level, the topology will remain the same. Okay, thank you. Thank you, guys. We can close now.